This video is going to focus on the different factors that affect the rate of the reaction. So what you want to keep in mind as we go through is thinking about a reaction happening on a particular level, meaning like on a particle level. So taking a magnifying glass and looking down at what's happening to the particles. Anytime that we could increase the number of particle collisions, we're going to have a faster rate, or we're going to increase the rate of the reaction. So the particles are colliding. When they collide and they have this effective collision, the more times we're getting them to collide, the faster the rate will be. The first factor I want to talk about is concentration. If the concentration of one or more of the reactants increases, the reaction rate will increase. And we've talked about concentration as far as the units, meaning we've talked about molarity and parts per million. So if you have a higher molarity value, so let's say a 3 molar solution versus a 1 molar solution, the 3 molar solution would have a faster rate of reaction. Another factor that increases the rate of the reaction is the temperature. Remember that temperature is a measure of average kinetic energy. So if you increase the temperature, the particles are going to be moving faster, so they'll collide more. We'll have a greater frequency of reaction. But also, when you increase the temperature, you're going to have more kinetic energy, so the collisions will be more effective. They're more likely to stick together and stay together because that increase in kinetic energy. Another factor that affects the rate of the reaction is surface area. Remember when we were doing the lab with the candy hearts, we saw that when you had granulated sugar, it dissolved faster. The rate of the reaction happening was faster with more surface area. And the reason why is because you're going to have more collisions. So more collisions, faster rate. You have more surface area, there'll be more, in that case, fresh portions of water brought in contact with the solute. Another factor that affects the rate of the reaction is pressure. If you increase the pressure, you're again going to have more collisions. But this is only true for gas particles, and we've talked about this a couple times now, that pressure only affects gases. So if you think about, for example, a piston, and you push down, increasing the pressure, the particles are going to be closer together, so it's more likely that they're going to collide, again, increasing the rate of the reaction. Next, we want to talk about a catalyst. A catalyst is something that speeds up the rate of the reaction. It doesn't get consumed in the reaction, meaning it doesn't get used up. And what it does is it lowers the activation energy. So it's an alternate pathway. It has a lower activation energy. It's kind of like if you want to think about a mountain climbing up a hill, and then you have this shortcut in the mountain. So it's the same starting point, same reactants. You have the same products, the same endpoint. It's just a little faster alternate pathway to get there because it takes less energy. It lowers the activation energy. We often draw this as a dotted line on our potential energy diagram. We do need to know that even though catalysts speed up the reaction, they do not change the value of the delta H. So remember, delta H is products minus reactants. That's not going to change with a catalyst, meaning your products are the same, the reactants are the same. It happens faster, but the heat of reaction is unaffected. The last thing we want to talk about as far as affecting the rate of the reaction are the nature of the reactants. So nature of the reactants will depend on, if you have more bonds, it's going to go slower. So for example, you could have a single bond, triple bond, double bond. When you have a triple bond, it's going to take longer to react. Every bond you have to break takes a little bit longer. So single bonds react the fastest, then double, then triple as far as covalent. The other thing is that if you have something ionic, it will go faster than something covalent. Remember, ionic are more just like this attraction between positive and negative ions. There's not actually bonds that you have to physically break. So ionic, and especially if the ionic substance is in solution, like aqueous, it will go faster than covalent. And the last thing I need you to write down in your notes, on the bottom it asks you to summarize the factors that affect the reaction rate, and you could do that there. But I also need you to write down, there are two things you need in order to have an effective collision. Meaning that when you have two reactant particles come together, they don't necessarily have to have what we call an effective collision. So the first thing that has to happen is when they collide, they have to come together at the right angle. So you need correct angle of orientation. If they don't collide at the right angle, they're not going to make an effective collision. And the second thing is they need enough kinetic energy. So we call that sufficient kinetic energy so that they actually stick together. So somewhere on your paper, if you could write the two conditions you need for an effective collision, and that's correct angle of orientation and sufficient kinetic energy.